Hello, my name is Gurnoor and this is my video submission for matrix multiplication task. The first part of the task required is to create a multiplication program, but in a sequential method. And I'm gonna show this here. So as you guys can see, I've made my declarations and then generate matrix function is being used in order to in order to basically assign various values into a matrix. Afterwards, we have an unsigned long integer here, and this what it does is basically declares the matrix size, and afterwards we have allocation of matrices, that is A, B, C, and C. Afterwards, generate matrix function is used, and what it does is basically initializes matrix A and B with random values. Afterwards, we have the core of a program, that is three nested loops, which perform the matrix multiplication of A into B, which results in the output matrix of C. And basic, yeah. Afterwards, we have calculation functions for calculating the time that is being done. Uh, and afterwards, you have a function to basically print the output into a text file. And then the program basically ends with delete functions here. And these are being used just to free up the memory, because we are using matrix of very big size here. And any sort of memory leak should be avoided. So yeah, I'll just run through this program now. Yeah. Just aside some. Let's compile this. Oh, let's clear this. Plus tricks. CPP. Tricks. See, compiled, run, matrix. And the number of threads I wanna assign here is 4 per se. No, I'll just 2. See. Okay, so I have my output here, and this basically took a good amount of time, as you guys can see, uh, almost a minute here for calculating this program. And this is not feasible or productive enough for larger matrices as well as programs, since it's much more slow and basically a user cannot wait this long. So in order to improve on this, we have parallel multiplication. And just an example here, let's say if I increase my number of threads as well. I'm gonna wait for the output. This is again taking much longer. Well, this just proved that sequential programs are generally not productive enough. I'll just wait for the output here and let's see what happens. This should be, since I've taken number of threads as 4. Yeah, again, it took much more longer, even though I increased the number of threads. Since we're using a large matrix here, this is just not productive enough in order to execute a program. And that's why what we will do is basically parallelize this program so that we are much more productive in this calculation. And then to do that, I'll move over to my second program here. Yeah. So one of the basic thing that I was going through was if I use the pthread.h, somehow my environment does not accept that. I don't know for what reasons. And that's why I went with the thread vector library. And you can see, so the difference here is that the function to generate matrix value is quite similar here. But now I use a struct here that is thread data, which has 3 pointers, A, B, C, and C. You have the matrix dimensions and then integers telling, okay, that telling the thread which rows of C to compute. And then we have thread function for multiplying. And what does basically multiplies the matrix. Instead of using this does use three nested loops, but in a different way, as you guys can see. And then for assigning size of matrix and number of threads, obviously, and allocating matrix memory, generating vectors in A and B, and then assigning and creating the threads over here. And afterwards, all those threads are joined before our output is calculated because we want to avoid the race conditions that occur in the program when it's executed parallelly. And this has been done much more manually here. So what I'll just do is execute this one and show what are the outputs. Get done that. Mm. The thing that I want to do here is check out. Okay. So the matrix size that I want to allocate here is 2000 and the number of threads that I'm going to allocate here is 4. And let's see what are the results. So yeah, 8 seconds. So we can see that when executed, or basically when the program is parallelized here, in case of larger matrices, uh, it's much more productive to use parallel multiplication time since it's only taking 8 seconds for a 2000 size matrix. And this will be much more less when we are doing smaller dimension matrices, but obviously this is more productive than the sequential programming. And then I have used 4 threads here, and I use 4 threads in our sequential program where it took a minute to calculate this matrix multiplication. This only took 8 seconds here, and this shows how parallel programming is much more productive in case of larger programs. But if let's say I want to do tasks much more productively and use a better library in order to get the task done, I'll use OpenMP since it's going to be much more easier in OpenMP to parallelize the program. Here, as you guys can see, I had to create a thread function to allocate the matrices, sizes, and pointers, and then multiply them as well. I'll just move into my OpenMP program now. OpenMP. Yeah. So this is my sequential program parallelized by an OpenMP. And since I have declared the header here, you can see it's very similar to the sequential program since similar generate matrix function for assigning values, then my assigning my matrix size, then allocating matrices, generating them uh, by basically giving random values, setting the number of threads here. Then also in order if I move into my core program, I have used three nested loops, which I did in sequential program here as well. But only difference is I have written pragma omp parallel for, which basically parallelizes my outer loop and makes it easier for the program to execute. And then output time is going to be shown out here, printing the file to an output file, and then also freeing up my memory in order to avoid any leaks. And as you guys can see, as compared with my second program, this is much more shorter here. So OpenMP, what it does is basically offers me an opportunity to make my program parallel in a more productive way. Let's see if I can, yeah, compile this. It's F MP matrix dot cpp minus matrix matrix open np dot exe, and then assign my size and number of threads here. All right. Yeah. Oh, shit. Oh yeah. So I have my output here, and that is 12 seconds. This is sort of longer than my parallel program that was being done through threads. But as you guys can see, it's much more easier to execute it by this method. And since my number of threads here set are 8, let me run this through one more time and see if I can have a better output. Yeah, so I got 11 seconds here. Uh, this is quite similar to what we were getting in our second program, but as you guys can see, uh, it's much more easy to execute. And basically, OpenMP programs are much more productive when we are dealing with short matrices, that is 500 or even 1000. But this is a much more of a larger matrix. That's why it took up to 11 or 12 seconds. But overall, this explains the idea of parallel and sequential programming, that how parallel programming is much more productive and easy to do as compared to a sequential programming. And yeah, that's it. That's my video submission for parallel matrix multiplication. Thank you.